Hey everyone, thank you for joining to our weekly machine learning study jam. And previously, I'm really glad to see new faces. I think if I'm reading correctly, it's Neichi. And previously, we have covered already like some basic concepts like loss, linear regression, and last time we covered the concept of regularization, L2 regularization. And we even practiced a little bit, training our model using this method to conceptualize the model to for the tasks that it wasn't trained before, to increase our accuracy and avoid the overfitting. And Abdullah made a great job outside these study jams, and he spent some time to train the model and change some parameters to see how the accuracy will change. And could you please, Abdullah, share your findings, your discoveries, what you have learned, and maybe share some advices, what others should try to do?
Can I share my screen?
Sorry, let me allow, yep. Just a quick update. This is actually a really nice news for our GDSC study jam, because these study jams were aimed to gather together and to learn from each other, not just like workshops that someone is teaching others. And I'm really glad to see that you are trying new things, you're trying to learn on your own. Okay?
Okay, can I start? Yeah. So last week we are playing with Kegel what? Telco churn. Yeah. So maybe for a quick review, this is just my Google notebook. So if we import the data, we have covered this and do some data preparation, blah blah blah. Okay, so the interesting thing is here in the y value in the target output variable with different variable, a different parameter. Actually, there's some imbalance in which the customer who return is much more smaller, like one third compared to the customer who, or the other way around. Yeah, I think yeah, there's some imbalance. So what I did is to make this thing in balance. I mean, make this to number of what turn customer in balance. We could do some oversampling. So I apply smooth in which synthetic minority oversampling technique. So yeah, let's import the smooth from this library and then define the smooth parameters. Just yeah, selected minority, random to just random state, and then do the fit. Then this command will make more sample, so we get same y number of turn and not turn customer. Okay, actually, after doing the smooth and train this data, it's very hard to get accuracy more than 80%. I try to change like parameter and thing, but it's not going so well. So it's just around 8, 0.8. Yeah, it's hard. So maybe this is not this model is not a good model. We can try another model in which I try XGBoost. Yeah.
Excuse me, Abdullah, may I ask some question?
Oh, yeah.
So when you resampled this data set and you applied the model, did you include the regularization?
Include what?
Regularization.
Yeah, I include regularization. Actually, our model doesn't suffer from overfitting, so regularization is not so
Useful, right?
important, I think. Yeah, so useful.
Yeah, thank you. Okay.
Yeah, actually, I ran some. Wait a minute. I lost it. Okay. Yeah. So where? Yeah. So what I did was to make model from another I don't know, another method. So if you are familiar with random forest, so this is a variation of random forest. XGBoost is extreme gradient boost. So yeah, just import the library and then define the model, which I don't change any parameter. Just extreme gradient boost classifier, and then fit the model and do the prediction, and it's like getting accuracy 86%. Yeah. Okay, I think. Actually, I also did something else. So yeah, maybe until this point first. No comment? No, yes. So if you are like confused which model is best for my data, you can try a lot of model at once. This is not a full model like this one, not a Keras model, but this is like a more simpler model which usually works well with smaller data sets. So maybe our data set is small, so this works better. So this is too many. Yeah, the point is we.
So did you just Googled different like models that are there and just try to run all these models on your data?
Yes.
Wow, it's a really nice actually approach, because we haven't learned that much data models, but we are like, it's nice that we are curious to try and see the accuracy if we apply different. Yeah, it's nice. I really like it. And what was the like conclusion? Did you manage to run all of them? And okay, so you have this.
Yeah, this is.
I see.
Yeah, I try several models. I don't even know what this model is. SVC, new SVC, season 3, random forest, XGBoost, gradient. Yeah. So yeah, gradient
I think we used random forest classifier before. I think. Yes.
Yeah. So yeah, random forest classifier did better, like 86%. Yeah. So
yeah, I think I really love your approach. Like you first did some data exploration. You noticed that our data is not equally distributed in terms of the data for like ones and zeros. And the first thing is that, and the second thing, the whole approach of your studying is based on the experiment, right? You just try to resample this data and then see the results. Okay, it didn't work, it didn't improve much, but then you tried another like boost algorithm and you saw this, it didn't also maybe a little bit improved, but then you like run different kinds of algorithms, and it's all about iteration. Yeah, I think this is what as I understand machine learning like engineers maybe do. They just run experiments and see the result, and maybe most of the time they spend the hours to learn from data, adjust data, and then only run algorithms. Is there anything else you would like to share about your studying, self-study?
Actually, we should cover more EDA. I think I'm still cannot understand this much. I mean, explore data analysis, because our data is not so good like this. The distribution of tenure and monthly charge and total charge is kind of weird. I don't know if this thing will affect the model or not. Usually people do normalization towards their data, but I don't understand how to normalize this thing.
Yeah, good point. I think actually we should start from data analysis first, I think. Yeah, but I was thinking, okay, so if we are aiming to understand like machine learning, maybe we should start like from the crash course, brief introduction on the basics of machine learning, and then dive into like details in data analysis. But I got you. I think we already ready to some nice analysis of the data, exploration of the data, normalization, cleaning, and stuff. Yeah, thank you. Thank you for the feedback. Awesome. I really love this.
Thank you.
Does anybody else have questions, Steve or Neji? Okay. Actually, I wanted to continue this machine learning crash course today, but I certainly hear your feedbacks, and I will try to prepare more data analysis study jams. And if you find some tutorial that you're following, please share with us, and we can just move to these tutorials instead of machine learning crash course. And this is now the content that we are covering. For NATI, this is the amount of things that we learned, but I want to warn you that, calm you that this actually mostly just videos, and it's not, this machine learning crash course was not done for us to understand all the details. I think it's more about the overview of some basic concepts like reducing loss, generalization, what the feature crosses are, regularization, and other stuff. And actually, we've covered these all simple concepts before, and we are now in the process of applying our knowledge to some real, or how to say, some examples, not the real data, but some examples like classification problems, some neural networks and stuff. But during these small study jams, we actually already tried computer vision basic programs. And today we're gonna learn about a logistic regression. And what is the logistic regression? So before we were training our data to predict some classes of objects. For example, even for the computer vision problem, we classified images into different fashion items like boots or stuff. And we also, I think, covered examples of predicting the prices for the houses. But not all the time we're going to have these kind of problems. We might have the task to predict the probability of classifying some objects into one or another class. And logistic regression is used to generate these probabilities of the value between 0 and 1, instead of just classifying to 0 and 1s. For example, if we have the spam detection problem, we train our model to predict whether this email, for example, is spam or not, and it will give us the percent probability whether this email is spam. And if we test our model on the test data, and for example, it gives us 0.93 value, it means that the new data that we feed into our model is likely to be 93% spam, and the rest is not spam. So let's see the explanation by the instructor.
Let's imagine for a second that we've got the problem of predicting the probability of heads for some coin flips where maybe the coin is slightly bent. You might use features like angle of bend, coin mass, all kinds of stuff in there. What's the simplest model you could think of using? Well, we could maybe use linear regression like we've used before, but there might be some weird things there. For example, what if we have a new coin that we're predicting on that has a very heavy mass we've never seen before? Or what if we have an extremely large bend of the angle? We might end up with predictions that are outside the range 0 to 1. That would be really weird for probabilities because probabilities are a special thing. Probabilities are bounded between 0 and 1. And if we have a prediction model that gives us a value outside that range, we're going to be in trouble, especially if we say, try and multiply predicted probabilities or use them to create expected values, stuff like that. Well, as a first hack, you could try and cap that prediction to ignore any outlier values. But now we've introduced bias into our model, and we're not going to be very good there. So really the right thing to do is to come up with a slightly different loss function and prediction method that allows our values to be interpreted naturally as 0 to 1 probabilities and never exceeds that range 0 to 1. So we call this idea logistic regression. It's a prediction method that gives us well-calibrated probabilities. And these are fantastically useful. We can use these as real probabilities and multiply them with things to get expected values, and use them also for things like classification tasks, where we really want to know the real probability that an email is spam or not spam. So let's take a look at how this might work. We take our familiar linear model and we stick it into a sigmoid. And a sigmoid is basically something that gives us a bounded value between 0 and 1. There's asymptotes, so it never quite hits 0 and it never quite hits 1. At training time, we're training using a different loss function. As we said, squared loss is not going to cut it here. We use something called log loss, that if you squint closely at the formula there, it looks very similar to Shannon's entropy measure from information theory. Now, you don't need to understand the math to be able to take a look at the graphical interpretation, where you'll notice that as you get closer and closer to one of the bars, the loss gets very, very high quite quickly. Again, we see those asymptotes coming into play. So those asymptotes are actually quite important to think about in terms of learning. Because of those asymptotes, we will need to really incorporate regularization quite explicitly into our learning. If we don't, then on a given data set, the model may try and fit our data ever more closely, trying to drive those losses near 0. So L2 regularization can be extremely helpful here to make sure that our weights don't go crazy out of bounds. Why do we like linear logistic regression? Well, one thing is that it's really fast. It's extremely efficient to train, and it's efficient to make predictions. So when we need a method that scales well to massive data, or that we need to use for extremely low latency predictions, linear logistic regression can be a great choice. If we need nonlinearities, we can get them by adding in feature cross products.
Okay, and here are, as always, the theory written in these small blog posts, and they also discuss how to calculate the logistic regression, these probabilities in these small how to say, paragraph. And I recommend you to study this on your own to understand more in detail how to calculate it. It's all about math. And here is the explanation on the loss and the regularization, how it is used or combined with the logistic regression. And I think we can proceed with the classification, because it's logistic regression is one of the methods to use for the classification. But before we go to this topic, I want to have a small practice of regularization. And if we have time, I think we will have time because it's a small problem. We will next move to the classification. So as always, let's open this Google Colab file. And let me just share already prepared file. I hope you can open it. Let me know if you can't. And here I just created numbers and trained our model on numbers. But okay, you are requesting, so I understand. And Nietzsche, if you also need the access, you can just ask for the access. Otherwise, you can just see what we are doing. Maybe this is the first time for you to work on Google Colab. And this is the place where we can run our models. It has the, so it has the everything necessary, like the libraries installed, maybe not all, to run the machine learning models. And first thing first, we need to import libraries to define models, to work with data. I'm explaining in case Neichi is not familiar with this. So we use import statement and import the modules, which is like libraries or like the paragraphs from the libraries. We name this initial library, then it's submodule, and then the module that we are, and then the Alice, it's called Alice, or the names how we save our imported modules. So we import matplotlib, pyplot as plt, the shorter version of this name, and import numpy as np. And this is this library is for plotting some graphs to visualize the data. This is to work with the data as a data frames or as arrays. And sklearn is to define our model and to retrieve some parameters like accuracy or other parameters. And here we just click on this play button to import everything or to run the program in this cell. Now we're gonna create fake data, which is super simple. We're gonna save it as X and Y variables. X variable is the array, which I use the np.arrange method, which will create equally spaced numbers from 0 to 10 or 0 to 9, I should say. And we reshape it with the -1 to 1 arguments, which will create enough columns, which is 1 column for the 10 rows. And our Y will be the values for these for these keys. So we have, for example, 0, its value is 0. Then we have 1, its value is 0. 2, its value is 0, and so on. And this is our training data. Okay, so I'm going to run this cell. And then if I'm interested to see how my data is looking, I'll just print X. So you see it's a nested array because we're gonna have the first column here is our keys, and the next column is our values. And then y is going to be just, okay, you just see it, it's an array, but I'm going to print it as well. So this is just array of the values. Now we're gonna define our model as logistic regression. This is the topic of today's study jam. And logistic regression has different parameters. Some of them are already defined as default, and others are you can modify them. The solver is just a parameter that specifies the way we're gonna define our model. It's going to be liblinear, and then random state 0 is another parameter which also specifies the I think maybe something, I forgot what does it mean, but I think we can even just define it without this solver, because liblinear, I think it's a default parameter. So we're gonna run this to define our model. And after we define our model, so defining the model, which can be simply explained, is just defining what type of model we're gonna use for training our data. And then to actually train our data, we use the .feed method, and we feed our values x and y. Okay, so it prints us the model that we are using. Now I'm going to share with you some methods to retrieve some data from our model. We can use the .classes method to see the classification of our model. So we have here 0 and 1s because we only classified into two groups, right? So I just run it. And we also have the .intercept and .coefficient, which are the like B0, B1, the slope and intercept values. And we're gonna also, okay, run this. And we see that the intercept is equal to -1, and the coefficient, the slope, is equal to 0.5. And then we can run our model to predict the x and y, to predict the y values. So we're gonna run here on the same data set, but it's not the correct way, because we usually use the split data method to split into train and test data, or I should say train, validation, and testing data. But here we're gonna just, I'm going to just explain conceptually how we use logistic regression. And here we use the predict probe A probability, this method, and we parse the x values, and we're going to have as an output an array of the probabilities. And what does these two columns mean is the first column is the probability that the value is 0, and the second column is the probability of whether this value is 1. And we can see from the first row, the example, that our model predicted that the first number of index 0 is has the probability of 74% that is 0 and 26% that it's 1. And the same for other rows, for other 9 numbers or 9 data points. Here is the method that helps us to see the probabilities, but we also can visualize the predicted value itself. So it's going to be, it should be just the same as we could infer from these probabilities values. So we have here .predict method to predict y values given x. And here's the array. And we can see that it almost predicted correctly the initial values of y. And how to calculate or compute the score, the accuracy, we just use the .score method. We put x and y's, And see, it's 0.9, so 90% of accuracy. And another thing that helps us to see how accurate our model is the confusion matrix, which consists of 4 different, how to say, parameters or groups. And maybe you know that we can have false false negatives, true negatives, true positive, and false positives. And we can calculate how many values that we predicted lies into these 4 categories. Using the confusion matrix, we parse the y values that we predicted, the y values which are the ground truth, which means the value that we labeled values, labeled data, and then we use the predicted values through the predict method. And it's going to be, the output is going to be an array consisting of 2 numbers. It means that 3 are false negatives, 0 is true negative. Oh no, I should say true negative is 3, false negatives is 0, true positive, false positive is 1, and 6 true positives. You can see it from this array. So we have here 3 zeros, but it should have been 4 zeros. So it means we have 3 true negatives and 0 false negatives. But instead of having just 5 positives, we're going to have 6 positives and 1 false positive, right? And better to visualize this array is just using this matplotlib library to make a heat map. The colors represent the same or different numbers. So it's actually similar to this, but in a more maybe fancy way to see as a graph. Maybe it's useful for your reports or progress in your lab or in your studies, in your project, startups, and anywhere. And if we want to see even more detail on some our model, how it worked, we can use the classification report and also provide the same parameters to print all the F1 scores and the accuracy and so on. If there are no questions, then maybe we can start using the classification problem to learn about the regularization, not regularization, about the linear, what's it called? Regression, logistic regression. And we're gonna use the digits dataset, which is, I think I have imported it already. Low digits. Okay, so if you have the same, you have the same notebook, let's just run. It's not actually completed yet, and I use the tutorial, this one, and there are more information on this, more explanation, maybe details on the previous example and the example we're gonna run now. And let's start again with importing the necessary libraries. So I'm going to run this cell. Again, we have here matplotlib library, pyplot, numpy, sklearn, and we have here some dataset module to load the dataset. So it's built-in datasets. We don't need to download or create our own data. Then we have the linear model, and this is module to use the logistic regression, which is the topic of today's study jam. The matrix is just as before. We retrieve some report or the positive, negatives, data, model selection, train and test split. So this is actually what I was talking about before. This is to split our data into training and test data, and pre-processing some standard scalar. So this is maybe the only thing that Abdullah is interested in here, how to a little bit normalize our data. So next thing we need to do is to load the digits. So what's the data set actually that we are using? It's images that are stored as arrays. So I'm going to just load them first, and then we can see how our data is looking. And I'm going to run X, and you can see it's arrays. So it's a nested array because we have about 180, like almost 2,000 data sets, if I'm not mistaken. And each of these arrays is one handwritten digit, and the numbers are the pixel values. And the Y is consisting of the array of 9 integers, which are from 0 to 9, because this is our ground truth, or the actual types of digits we have from 0 to 9. And then we're gonna split our data. So this is the format how to split it. We define X train, X test, Y train, and Y test. And why we do this? Because when we train our data, we're going to use X train and Y train. And when we test our data, we're going to use the X test and Y test, but this is going to be our output. And then we use train test split. We provide X and Y's that we have loaded. The test size 0.2 is as the name suggests, is the size of our test data. Like the percent, like 20% from the whole data is going to be our test data. And then the random state 0 is here. It's a random number generated to like get randomly samples of data in order to avoid some patterns, unnecessary patterns. So we're gonna run this one. And then, sorry, I have not prepared the whole page. So the next thing we're gonna do is to normalize a little bit our data. And we're gonna use this scalar. And we define the standard scalar. We're gonna modify our X training data to actually, they explain that in this, oh, have I shared with you this page? I forgot. Oh, I didn't. Actually, this is the page, the machine learning crash course. You can also open it. It explains how do we calculate. We need a mean value, and then standard deviation value, and then we subtract our data. We subtract mean value from our data and divide it to the standard deviation. And then we just going to model and train our model. So as before, we used the logistic regression, and this one was before, random state was before. This C value is the parameter for the regularization. So regularization was the topic of the previous session, but I'm going to just quickly recall what that is. This is the method to generalize the model. So sometimes we have our training data. So when we train our data, we are interested in reducing the loss. And when we use the training data, when we train our model, we see the gradual maybe decrease in the loss. But when we use the validation test, we see that actually it doesn't converge, right? And one reason might be it's because our model was overfit to a specific data. It means that when it sees the new data, it cannot predict anything because it wasn't trained to do so. And the strength of the regularization can be changed using this parameter C. The smaller the parameter, the less strong the regularization is, if I'm not mistaken. So before we used C equal to 0.1, and I haven't told you that actually. So here it was equal to 1.0 because this is the default value. And we change it by just defining C in this parameter, 0.05. And then we use the multi-class OVR, and I a little bit forgot what does it mean. Maybe because we still don't know much about the parameters. I'm glad that we know this one. And then let's just define the model and run on our training data, okay? And here is when we define our model, we see the name for our model. And then, that's actually the explanation. So OVR says to make the binary fit for each class, and multinomial says to apply the multinomial loss fit. So this is the example of all the parameters defined in the logistic regression model. And you can study it a little bit more in detail on your own. Now let's test our data, see what we have. So we use as before, we use the scalar. So we're gonna normalize our data, our test data as we did for the training data. And then we're gonna predict Y values. So Y values are numbers from 0 to 9, right? And our X data is the arrays of pixel values of digits. Okay, we predicted. Why we don't have here any value is because we just save it in Y variable. And then we're gonna evaluate the scores using this method, model score. This actually, the other things are actually the same as we did for this simple training. So we have here X and Y training data, how our model scored for the training data, and then X and Y model score for test data. And I think I should have divided into two cells, or use the print statement to see both of these scores. Okay, so for the training data, we have 96% accuracy, and then, okay, so test data is 94% accuracy, not bad. And as usual, or not usual as before, we use the confusion matrix to see the so before we had just 4 cells in this confusion matrix, 4 squares. Now we have more because obviously we have more groups of data, right? And for example, how can we understand this matrix? Each column represents each digit, and then we see, okay, so the false positive, false negative is 27, and then, oh no, I think each row represents each digit, 0, 1, 2, 3, 4, 5, 6, 7, 8. Am I correct? 2, 3, 4, 9. Yes. So each row represents each digit, and here is the false negatives and false positives. So let me just print it with the matplotlib library, and we will see some arrows. It's not important. It's just about maybe it's important. It's font size. We haven't defined. Actually, I think let's define font size. I'm not sure if 12 is too much. Okay, it's working. Okay. Yes, so here is 27 from our if this is the from our prediction, we see that zeros were recognized 27 times, and once it was recognized as 2. Yeah, so the same goes for each number. So ones were recognized 32 times as ones, and one time as 2, 6, and a couple times as 8. Interesting, yeah? How one was written so that our model recognized it as 8. Interesting. So this is the confusion matrix, which just visualize exactly where our model was good and where it was missing some features, where it failed. And I'm not going to print the whole report. So I think that's the end of this tutorial, short tutorial, super simple, but I think we should start from simple models. So if you have any questions, you can ask and we can discuss. Otherwise, I think I'm not sure if we should go to this classification videos and tutorials. We can start it next time. And this is going to be a little bit different classification tutorial. We're gonna maybe do it next time. I think it's better. Okay, then thank you again for joining to this study jam. I really appreciate the work done by Abdullah and that you shared with everybody. And
question.
Okay, let's discuss.
So you split the train and test data, and then do the scalar only for the train data. Do we need to do the scalar to test data also?
Yes. Actually, maybe you missed on the 37th line. This one. I use transform scalar onto the test data.
Ah, I see.
Okay. Good question. Yes.
Thank you.
Thank you. So this is actually really basic problem and really not important, but I mean important, but it's a famous problem. Handwritten digits recognition. Even like when I was in undergraduate studies, I remember some graduate students were doing some research or something on this problem. So although it seems simple, I think there is something really interesting as we move towards some advanced topics. Okay, if there are no questions, then that's the end of this study jam. See you next week. Bye-bye. Bye-bye, Dev.